Assalamualaikum and hi. So this is steam turbine cycle part 4 of chapter 4. In this video, I'm going to explain subtopic number 5, methods to increase the efficiency of Rankine cycle. Methods to increase the efficiency of the Rankine cycle. Methods to increase the efficiency of the Rankine cycle. So this is the TS diagram of the Rankine cycle, and this is the simplified diagram of the actual vapor cycle. So as we all know, in the previous slide, I already explained the thermal efficiency of this Rankine cycle, which is equal to work net divided by Q in. It is equal to 1 minus Q out divided by Q in. And as we all know, we can increase the thermal efficiency by first increasing the average temperature at heat addition process, which is from process 2 to 3 there. And another method is we decrease the average at the heat rejection process at the condenser, which is at the process 4 to 1. However, actually, there is three methods to increase the efficiency of the Rankine cycle. The first one is the lowering the condenser pressure. By lowering the condenser pressure, which is process 4 to 1, we use even lower constant pressure, and so that we can get the low average temperature. And the second one is superheating the steam, T high average, meaning that we increase the temperature at state 3 to even higher temperature. And the last one is the increasing the boiler pressure by fixing the average temperature at state 3, temperature at state 3, and we increase the pressure of the boiler, which is constant pressure at process 2 to 3, so that we get the average temperature of the even higher average temperature of the process 2 to 3. So these are the three methods to increase the thermal efficiency of the Rankine cycle. Method 1, lowering the condenser pressure. So this is the TS diagram of the Rankine cycle, and this is how we calculate the thermal efficiency of the Rankine cycle. And as we all know, we can increase the thermal efficiency of the Rankine cycle by lowering the condenser pressure. And this is the TS diagram, what it means by the lowering the condenser pressure and T average. As you can see, we can decrease the pressure, which is constant pressure line there, into the 4 prime, 1 prime, and also 2 prime there. So by doing this, we increase the work net in. And the characteristic is the T saturated is lower, and the T steam temperature at the saturated is lower, and temperature steam also will be lower. However, we need to add additional heat input to the system. However, the ratio of the work in and Q in is small, and so we can assume it still efficient. And another thing is the moisture content will be increased and the vapor content will decrease, which are not good to the blade of the turbine. However, we can increase the work net, overall work net of the system, and also thermal efficiency of the system. And however, these cases we have a limitation, which by lowering the P condenser, which is the pressure of the condenser, we can have the air leakage into the condenser, and also we have this effective heat transfer, whereby the pressure of the condenser should not be lower than the pressure of the cooling medium. Let's say we use water from nearby pond or lake, so the temperature, the effective temperature is 10 degrees Celsius, and the pressure is at 3.2 kPa. So the pressure of the condenser should be larger than the 3.2 kPa. Method 2, superheating the steam at T higher average temperature. So this is the TS diagram, and this is the thermal efficiency. How do we calculate the thermal efficiency of the system? And to increase the thermal efficiency of the Rankine cycle, we can increase it by superheating the steam to a higher average temperature. Let's say this is the TS diagram. As you can see, what it means by the higher average temperature, we increase the steam to even higher temperature, 3 to 3 prime, so we can increase in work net. So the characteristic is work net will be increased, and the moisture content also will be decreased, and the X also, uh, which is the vapor content, also will be increased. However, we have a limitation to this process because 3 prime should be smaller than the maximum temperature that the blade can handle. And in nowadays, the maximum temperature that the blade can handle is 620 degrees Celsius. So if let's say we put even higher temperature than that, it will damage, or it will melt the turbine blade. Method 3, increasing the boiler pressure. So this is the TS diagram and the simplified diagram of the cycle, and this is thermal efficiency of the cycle. And to increase the thermal efficiency from method 3, which is the increasing the boiler pressure, fixing the temperature at state 3. As you can see, this is the TS diagram. What it means by this is we increase the work net by increasing the average pressure of the boiler to even higher pressure. As you can see, 2 prime to 3 prime. However, we have also decreased in the work net at the one which I shaded in the green color. So the characteristic of this method is the saturated temperature at the process 2 to 3 will be higher average temperature, and the Q in will be decreased since the process 2 to 3 is a bit shorter than 2 prime to 3 prime is a bit shorter compared to 2 to 3, and the Q out also will decrease. And however, the vapor content will be decreased and the moisture content will be increased. And however, we can compensate these drawbacks of the moisture by using a reheating system or reheating the steam. And for this process, we have limitations, and since if we increase the pressure of the boiler, average pressure of the boiler, which increase the work net, which are colored in the red shaded there, it should be higher than the work net decreased by the one which are shaded in the green color. So the total work net should be higher. 3 methods to increase the efficiency of the Rankine cycle. The first one is lowering the condenser pressure. So the condenser pressure will be lower, the average temperature, the low side will be lower. And the second one is superheating the steam at the even higher temperature. So we increase the pressure, the temperature at state 3 to 3 prime. And the last one is the increasing the boiler pressure by fixing the temperature at state 3. And as you can see, we have increase in work net and also decrease in the work net, the one which are shaded in the green color, and also the one which are shaded in the red color. This is the end of part 4 for chapter 4, and hopefully you enjoy my video, and thank you.